Hi Year 8, welcome to today's lesson on work done. I want you to write down the date and the title and the LO please, and I want you to try the starter task. So pause the video here and I'll continue in 5 seconds. Okay, number 1, what are the names of the two bottom chambers of the heart? So the bottom chambers are called the ventricles. We have the right ventricle and the left ventricle. Number 2, which chamber of the heart has the thickest walls? So that would be the left ventricle, and the reason for that is because it has to pump blood all the way around the body. Okay, so it needs to be thicker because it needs to push the blood a lot farther. Number 3, what is the name of the blood vessel that takes the blood from the right ventricle to the lungs? That is the pulmonary artery. So pulmonary means lungs, so both of the blood vessels that connect to and from the lungs start with pulmonary, and artery means it's taking it away from the heart. So number 3 is pulmonary artery. Give yourself a mark out of 3, please. Moving on with today's lesson, we're going to be talking about energy transfers. So energy is transferred mechanically, electrically, or by heating or by radiation. Okay, so mechanically means you are physically moving something, and that is what we call doing work, which is what today's lesson is about. But I want you to write those four ways that energy can be transferred, please. So mechanically, electrically, heating, or radiation. Okay, a system is a word to describe an object. When the system changes, energy is transferred. Okay, so the word system, all it is a fancy word for the object we're talking about. So say if we were talking about a car driving down the road, that car is transferring energy by moving, because remember, anything that's moving has kinetic energy. So that car is doing work. And because the car is the object we're talking about, that is what we call a system. Okay, so the car is the system in that case. So there's a car sat still, and when it moves, the system has changed. Energy has been transferred because it is now moving. Okay, if there is a closed system, it means that energy can't enter or leave that system. When a force moves an object, energy is transferred and work is done to the object. So if you pick up your pen now to write in your book, that pen was just happily on the table. You have picked it up, you have transferred energy into that pen because now it is moving up off the table. And it is also gaining gravitational potential energy because you are taking it higher off the ground. So you have transferred energy into that pen, and that is what we call work done. So anytime energy is transferred, it is just called work done. So I want you to write down those 2 bullet points, please. You don't have to do the full sentence, but I want you to make sure that you've got down that whenever energy is transferred, work has been done. Okay, there are useful energy transfers and wasted energy transfers. So you can try and think of your own examples, but I'm going to give you an example now. So when you plug in your hairdryer, electric energy is transferred into the hairdryer, okay? And then the fans spin round and blow air out. So that is kinetic energy. And that is useful energy because we want those fans to spin round and dry our hair. Okay, we want the air to be blown out for our hair to dry because that is what that specific object's function is. Okay, the wasted energy would be the really loud annoying noise that it makes, because we don't use our hairdryer just to make a really loud annoying noise. That is the wasted energy. Okay, so useful energy transfers is when the object is transferring energy in a way that we want, and wasted energy transfers is when an object is using energy in a way that we don't want. Another example is using a torch. So the light is a useful energy transfer, but if you leave it on for ages, it will start to heat up, and that is a wasted energy transfer. Okay, so try and think of your own example, please. Right, we are going to have an example now. So here I'm drawing a very nice, very beautiful, pretty unicorn. Okay, when that unicorn jumps up over the rainbow, it has done work, okay? Work has been done, and that is because energy has been transferred. So this unicorn uses a force to push itself off the ground. So it is moving upwards, it's using kinetic energy to do that, and it's high up off the ground now, so it's got more gravitational potential energy. Okay, so whenever energy is being transferred, work is being done. So while I'm explaining this, I'm moving my hands a lot. You can't see it, but every time I do that, I'm technically doing work, okay? Work has been done because my hands have kinetic energy because I'm moving them around so much, okay? And in this case with the unicorn is the system, okay? Remember, that just means the object that we are talking about. So the unicorn is the system, and it has done work by transferring energy. Okay, we have a formula for this that I want you to write down, please. So work done equals force times distance. That is the formula for work done. Write it down, please. Okay, and now we're going to talk about the units. So remember, units is just what we measure things in. So if you were measuring distance, you'd probably do it in meters. If you were measuring a longer distance, you'd probably be doing it in miles. If you were measuring the size of your pencil case, it would probably be in centimeters. Okay, we always need to make sure we put the units on the end of any answer we give, because if we just put a number, like say the answer was 5, then whoever's reading it is going to be like 5 what? 5 bananas, 5 camels, whatever. We need to put the units on, so make sure you know the units for work done, force, and distance. Okay, so force we measure in newtons, which is represented by a capital N. Distance we measure in meters, which is represented by a lowercase m. And work done is in joules, which is represented with a capital J. So whenever there's anything to do with energy, it's measured in joules. So I want you to get all of that down, please. It's very important. So pause the video here and I'll continue in 5 seconds. Right, an example. Luigi jumps 2 meters in the air with a force of 13 newtons. What is the work done? So write out your formula. So work done equals force times distance. And then we put the numbers into that formula. So we've got force, which is 13 newtons. So we've got 13, and then we've got distance, which is 2 meters. So 13 times 2 equals 26 joules. Excuse me. Okay, so remember, work done is measured in joules. So that is our answer. Now, rearranging the formula, we've gone through formula triangles before, but I'll go through it with you again. I want you to all draw this triangle, please, exactly how I've done it here. And then this helps us rearrange the formula. So we know work done equals force times distance, but what if we had the work done and the force and we wanted to find out the distance? Well, we would cover up the D, okay? So we want to find out what distance is. So whatever you want to find out, you cover it up in the triangle. And then remember that this line here is a dividing line. Okay, so we are left with distance equals work done divided by force. Okay, so we cover up whatever we want to find out, and then we do whatever's left. So work is above force, so that means it's work divided by force. This here is a dividing line. Okay, if we wanted to find out what force was, we would cover it up, and then we are left with force equals work done divided by distance. Okay, and that is how you rearrange it. So what I want you to do now is there is a worksheet with 30 questions on it. So it's got the question, and then it's got a hint next to it, and then another hint, and then the answer. So if I were you, when you get onto the page, I would zoom all the way in so you can only see the question. And then if you're getting stuck, scroll to the right a bit until you see the first hint. If you're still stuck, scroll across until you see the second hint. Okay, so please don't look at the answers until you have tried it. Now, I want you to send me your answers to the first 5 questions, please. So there are 30 questions. I want you to do as many as you can for practice, but I only want you to send me the first 5, please. Okay, so that is the end of today's lesson. I hope you all have a wonderful day.